Hi everyone. In tonight's video, we're going to do something a little bit different, something we haven't done before. We're going to look at different reference frames. We're going to look at Einstein, we're going to talk about him a little bit, and we're going to do all of this through looking at optical illusions. I'm sure that all of you are familiar with optical illusions. They're really a lot of fun and interesting and sometimes make you sit there and think about what you're actually looking at. We know that that's the way physics is. Physics is not all math and numbers. It really makes you think. And tonight, that's exactly what we're going to do. We're going to think. Tomorrow in class, we're going to talk a little bit more about reference frames, but we're really going to talk about our thoughts behind this. If you agree, if you disagree, just your personal opinion on this whole concept. Like I said, we're going to look at optical illusions, so let's get started. To understand why we see optical illusions the way we do, let's take a look at Einsteinian relativity. In Einsteinian relativity, reference frames are used to specify the relationship between a moving observer and the phenomena under observation. In special relativity, the distinction is sometimes made between an observer and a frame. An observational frame of reference is a physical concept related to an observer and the observer's state of motion. There are two types of observational reference frames, inertial and non-inertial. An inertial reference frame is defined as one in which all laws of physics take on their simplest form. In Newtonian mechanics, the mechanics we studied at the beginning of the school year, a more restricted definition requires that only Newton's first law holds true. That is, a Newtonian inertial frame is one in which a free particle travels in a straight line at constant speed, or is at rest. In contrast to the inertial frame, a non-inertial frame of reference is one in which fictitious forces must be invoked to explain observations. An example is an observational frame of reference centered at a point on Earth's surface. This frame of reference orbits around the center of the Earth, which introduces the fictitious forces known as the Coriolis force, centrifugal force, and gravitational force. All of these forces, including gravity, disappear in a truly inertial reference frame, which of course is one of freefall. A reference frame tells you what I am comparing my motion against. When I tell you that I am currently sitting and not moving at my computer while speaking to you, I am comparing my lack of movement to the room I am sitting in. I actually could be on a bus that is moving through town at some changing velocity. In my frame of reference, I am sitting still, but if you were to see me from the street, you would claim that I am moving. Frames of reference are especially important in special relativity because when a frame of reference is moving at some significant fraction of the speed of light, the flow of time in that frame does not necessarily apply in another. The speed of light is considered to be the only true constant between moving frames of reference. The result of a physical measurement often depends upon the frame of reference of the observer, as in the theory of relativity, and the act of making an observation can change the thing observed. Frames of reference and relative motion is actually the reason that people get carsick. Your brain is getting two different sets of information about your body's motion that might not exactly agree with each other, information from your eyes and information from your inner ear. Some people are more sensitive to these differences, which causes them to feel sick as they watch the road go by. As human beings, and as scientists in particular, we must observe carefully and objectively and guard against the tendency to see in nature only what we expect to see. Looking at optical illusions is just not a fun thing to do, but also educational. Scientists study optical illusions to get a better understanding about how our eyes and brain interact and interpret information. Optical illusions have practical applications today, too. For example, pilots can train on flight simulators that use optical illusions to simulate real events without ever having to leave the ground. I encourage you to replay this video and mute the audio. See if you can observe the optical illusions displayed in a different way. Perhaps you will see more than the image you saw before.